Good afternoon. How's everybody doing? We get some coffee, staying awake, not hitting that mid-afternoon sleepiness, are we? Doesn't look like we are yet. All right, good. And we've got some good content here at the community theater. My name's Austin. I work for Docker. I'm actually on the HR team. So I am learning a lot of new things about technology here. This is actually my first DockerCon. I've been at Docker for almost 2 years, but I wasn't able to go to Barcelona. I missed the last one here. So it's been a real treat to be with you all. And we've had some really great sessions here in the community theater, and we've got another one coming right up. So I'm going to introduce here we've got Alex. Let me make sure I can say this right. Alex Iankoulski. Close. All right. And Alex was an attendee back at DockerCon 2015, and he was inspired by that experience. And since then, he wanted to run everything in containers. He became an avid Docker advocate, a DockerCon speaker, and a Docker captain. So that is Alex. And we've also got Fabio Nonato. And Fabio is an advocate for containerized orchestrations of AI workloads, passionate about deploying them in production. And until recently, he didn't have pip installed on his Mac. I have no idea what that is, but he said, why should I install pip when I can do everything on Docker and just Docker build it? So I hopefully that makes sense to all of you. I don't get the joke, but it's not for me. All right, there we go. Good. Awesome. So I'm going to give it up to you guys. Take it away.
Thank you. Thank you very much.
Thank you, Austin. Before we start, in the spirit of DockerCon, Fabio and I will make the traditional sacrifice to the demigods.
There you go.
Okay. Today, we want to share with you a story which we like to summarize in 3 words: depend on Docker. In the spirit of DockerCon being a very, very demo-heavy conference, we're going to show you demos. We'll have a fun, generic AI example running in Docker, and we'll run it both on CPU and GPU. Then we're also going to show you how we take that into the industrial world of AI, and we'll run some industrial AI analytics. This is a very fast talk. We have only about 20 minutes, so we'll try to make this quick, and we'll leave hopefully a couple minutes for questions at the end. But if you have questions that you want to ask us later, please come and see us and ask us directly after the talk. So what is depend on Docker? First and foremost, it's a philosophy that says, don't install anything on your machine. Just run it instead in a container. And if there's no container for the thing that you're trying to run, well, build one and share it with the world. It's a pattern. Your project qualifies as a depend on Docker project if the only thing to install on your machine to go from source code to running software, even running software in production, is Docker. You're not allowed to install anything else. Then you can say your project is fully depend on Docker. It's an open source project. It's on GitHub, and it's very, very simple, because you can get started with your own dependent Docker project by just running this one command. It's flexible because it comes with reasonable defaults out of the box. It's a fully functional, working Docker container image that you can build, push, pull, and run right out of the box, just with this one command. And it's universal because you can do it on Linux and on Windows with the same ease. this is where I get to tell you why we love to depend on Docker. It's because before Docker, we had so much pain, so many blockers. We couldn't do so many things. And after we adopted Docker, we found ourselves being able to build, ship, and run at unprecedented speed. And very often, where the answer had been no before, it is now yes. Just Docker enables us to do so much more. So now, we have released the second version of the Depend on Docker project for this DockerCon. And we have made a slight addition to the build, ship, run workflow. We have added a simple testing framework to the Depend on Docker template. So now we can say we build, test, ship, and run. And we run containers everywhere. On edge devices, we run on Raspberry Pi, on NVIDIA Jetson. We run it obviously on our laptops and desktops. We run in on-prem installations in our local data centers, and we run on all the major cloud providers. Anywhere where there is a container runtime, we can run. We also use a variety of operating systems. And we run and build containers to do software development and develop applications for data science, machine learning, and AI. We also run at different scale, from single containers to hundreds of thousands of containers. So let's talk a little bit about running containers on CPUs versus GPU. So CPU is a generic processing unit that can handle various generic workloads. And that is very good for doing traditional machine learning. However, to do the really hard stuff, the deep learning models, which require very intense compute, you can only do this in a reasonable amount of time if you use specialized hardware like the GPU. The GPU cannot do everything, but it does certain things like matrix multiplication, for example, really, really fast, really, really well. And that is why it is perfect for building deep learning models. Today, to run a container on GPU, you have to install the NVIDIA drivers, and then just use docker run --runtime equals NVIDIA. There's more coming in the latest release of the Docker engine. You can do --GPUs, which makes things even easier. So we're thinking about what would be a fun thing to do here at DockerCon, how to show you an AI example that everyone can relate to. And we picked face recognition. To build this face recognition project, which is on GitHub and on Docker Hub, I just had to run this one command, curl run my bash script to create a Depend on Docker project. Then I picked image recognition, a face recognition model from GitHub. This is Adam Geitke's repository. It already had a Docker file and a Docker file for GPUs, so that was perfect. So I just customized the settings in my project. I ran the build script and the test script, then configured Docker Hub to do a continuous deployment of my repository. And now everybody in the world can do Docker run face recognition. You can go and try it today. It will work for you. What it does is basically you put faces of known people in a folder, then give the container a test image that it hasn't seen yet. It runs and it recognizes the people that are in the picture if it already knows their faces. That is face recognition, AI application, out of the box, in no time at all. To make things even more fun, instead of giving it just a couple of images, we've prepared a folder of images. So pay attention, I'll just scroll through. These are known people. Some of them are a bit tricky. And these are going to be our known people, folder of known people's faces. And here are going to be our test images. Some of those will also be tricky. Some people have glasses, some people looking sideways. It's a lot of fun. So, in my screen here, I have two windows on the left. The top one we're going to run on CPU, the bottom one on GPU, and I'm setting this just by setting processor type. And then I will run this script, recognize. So as you can see, this is doing a Docker container run in both windows. The top one is going to run the same container on the CPU. The bottom one will run on the GPU. In the top right, we have the CPU utilization of this machine that is running the containers. And you can see that as things start getting processed, our CPU utilization goes up to 100. And the same thing on the bottom right, we have the utilization of the GPU, as you can see the processes spinning up and the GPU utilization going up to somewhere like 30% briefly, because this is a very, very small workload for a GPU. And we get the same answers in both screens. So we successfully ran on both CPU and GPU. The answers are perfect. All the images were recognized correctly, but here are some highlights. The first row, you have that person with the face mask on. That's our training image. And then for our test image, the person is dressed in armor. He's looking down and sideways. There's no problem. The image model detected it just fine. Power of AI. Second example, the training image is a famous NASA astronaut, Dr. Story Musgrave. This is a contemporary picture, and in the test image, he is a little over 25 years younger. It's from the time when he was on active duty, flying on all the 5 space shuttles. There was no problem. Face recognition detected it's him. And that last example is me from DockerCon 2015. And the test image is me on the roof of my house. And the model said, no person found. But that's one case when I agree with the model, because at that time I was feeling more like a monkey than a person.
Yeah.
So let me pass the mic on to Fabio to show you an equally interesting example in the industrial AI world.
Thank you very much, Alex. Very excited to be here and talk to you guys about how we actually depend on Docker for our industrial AI applications. But before actually going into our applications, I just want to set some of the context of actually what we're doing and what we talk about. Usually when we go at try to tackle some industrial applications for machine learning, data science, and AI, you almost always hear the predictive maintenance use case. That's when a customer comes to us with a piece of equipment. Sometimes time series that represents the state of operation of that time series, of that equipment, and we are set to build models that are actually identifying if that operation is normal or anomalous, right? When you do this to this small scope, you actually build very good models to identify anomalies on the data. The system itself has to be contextualized within, the equipment has to be contextualized within the system it sits on, so that you can actually understand a little bit about the process and how actually that piece of equipment gets affected by the whole end-to-end refining, for instance, use case that we're showing on the left-hand side. And on the right-hand side, we start to see the graph that actually represents that system. You start to get from a handful of time series to hundreds of sensors. That scale is okay-ish, up until when you actually look at a real asset. Let's look at an offshore platform. This is kind of the scale we're talking about when we're trying to look for operations states on a real asset. So we're talking about not a handful, not 100, we're talking about tens of thousands of time series. So pretty beefy, pretty big. So for the data scientists in the crowd, yes, the chill down the spine is justifiable. It is a big, big, big problem. We're talking here about building not necessarily 1, 2, 3, but hundreds of models, and not building one model 100 times. We're talking about building 100 unique models that are gonna each one represent a piece of my operation. Cool. We're set off to build a lot of models, and scale, it becomes a big issue on industrial applications. So what do? We try to automate, right? We like to depend on Docker, we like Docker, we actually love it. We love to automate those workloads. So we start off by trying to use very cool container orchestration tools to kind of automate our pipelines. And this is the case where we're trying to automate the actual model building phase, so taking out a little bit of the trial and error type application from the hands of the data scientist and giving the data scientist a tool to actually execute that model exploration. This is actually our probabilistic evolutionary framework built on top of Kubeflow pipelines to do architecture optimization, architecture search and hyperparameters optimization. We start off sampling this space of models that we can build. Then we build probabilistic meta models of the actual objectives we want to optimize. And those meta models go into genetic algorithms and other evolutionary methods to optimize and get to the next model we're looking at. Then we end up with pipelines that look like the one on the left. Very big. Now, we solve half of the problem of scale. We solve the, can I automate the workload? There you go. But we're still missing, okay, I still need 100 times my data scientist to go there and click deploy, click run, right? That's how, if you look at KF Pipelines Quick Start, you're going to be suggested on how to deploy your pipelines. So that got us thinking, and we decided to act on an idea, and we decided to, actually we thought about something like, okay, if I had a REST endpoint where I could just go and post a tarball pipeline into my Kubeflow cluster, and that would run the pipeline for me without me having to be in the pod itself, that would be neat. I could have all the data scientists just use that. Romario was born. So Romario is this a very lightweight, tiny service that gets deployed into a Kubeflow cluster. And it just stays there at the right place at the right time. You pass him the ball, and it's going to run. That's about it. You pass it the tarball, it's going to run. Much like the 1994 World Cup soccer player Romario. He's there, waiting for the ball, and he's going to score. So instead of actually talking about Romario, let's try to show Romario a little bit. Okay, so as you can see, Romario is also an open source project within our Git, so do check it out. It's there, it's available. And on the left-hand side for you guys, you see two terminal screens, both at the same location. It's a management node for a couple of Kubernetes clusters that we have. So if I go into Kube CTX here, we have a few clusters available. The context is in a cluster that actually has Kubeflow on it, so we're going to play around with that. Because Romario is a full automated dependent Docker project, I can just go and run it. Okay, so I'm going to run on my management node, my container, and it's going to give me a bash screen into Romario, right? Still, I'm not in the kubeflow, right? Because right now we haven't deployed Romario yet. So I can use one other automated script, which is the execute script, and I can watch for my kubectl get pods. Now our watch begins, and we see that there's no Romario there, right? The services that you see here are basically the usual kubeflow services. You see pipelines, you see TensorFlows, you see PyTorch, but you don't see Romario. So if I have a Romario image running on my management node, I can just use one of the scripts that we have here, like deploy Romario for management, and there you go. Now I have Romario in my cluster, so he's at the right location now. So container is creating. It takes a little while. It's a tiny service, but it comes with an image, and that's going to give us an endpoint so we can actually curl some stuff into it, right? So let's just check what we have to post to it. So we have a couple of basic pipelines. It's actually the first one is the example that comes with kubeflow, the conditional example, a fun one, flipping a coin. The second one is that optimization workload, right? Oh, the service is ready. So Romario actually gets me an endpoint. We exposed it to a URL here, and there you go. That's Romario. It's working. I do have a Swagger API for this, so I can go API docs. There you go. Yeah, here we go. The service, it's very bare bones. The open source version of it basically has its post command. I could use the Swagger API to actually try it out. I can just choose a file. Maybe that basic thing, which is the flip a coin pipeline, we can open it and we can execute it. And it should post that pipeline into my cluster. Oh, there you go. Yeah. See? So from my Mac, I just curled that little tarball into a kubeflow cluster in GCP. Cool, right? Not that much. I really don't think it's cool because I can do that from the kubeflow UI too. Yeah, right? I could come here and just upload a pipeline. So we're all about automation, right? So let's actually do it an automated way. So instead of running the small pipeline, let's run the big one. I'll just, well, it's 2019, so I do have the test framework, right? So I'm going to use a test script that we have that is a post that's just going to post it from somewhere. So I'm curling it from inside the Romario container running on the management node. And I do have the pipelines. We already looked at them, pipelines, and the run one is the big one. So if everything works well, oh, there you go. Success, success, success. There you go. You see the first container creating. That's sampling the space. And I think if I go back to my kubeflow screen here, let me refresh this and look at my experiments. Oh yeah, there you go. We see a new experiment that was just created, and we can actually see the pipeline running. Yep. And remember that I said we need to build hundreds of models? Yep, there you go. We just kickstarted basically 110 deep learning model train jobs with a curl command from a bash script running on the management. Cool, isn't it? Cool. With that, back to you, Alex. That's a good demo. Thank you.
Awesome job. Awesome. It's unbelievable. The only thing he needed to do all of this was Docker. And I want to say, I hope we convinced you that you can depend on Docker for AI applications. We have a special prize for you. This is a Depend on Docker for AI sticker. You can't get that anywhere unless you earn it. And every one of you has earned it because you were here at this talk today. So, we are past our time, so I don't think we have any time for group questions, but please come see us, get your sticker. Also, we have our colleague Murli here who is ready to give out stickers. Please see one of us to get yours.
Awesome.
Thank you very much. Thank you.
And let's give it up for Fabio and Alex. Thanks so much, guys. Yeah, we don't have time for questions, but they will be here after, and you got to go get your sticker. That is a hot commodity here at DockerCon. Make sure you get it because you earned it. Thanks, guys.